Okay, look at this figure. There's a ball here on the two oblique surfaces like this. This object has a mass which is m. Okay, what is the free body diagram for this mass? Okay, at first separate this object. So you have this figure here on the right side. First, you have weight force downward. I'm sorry, it is W. The next one is reaction force or normal force. Pay attention, please. Reaction force is normal to the surface. It is always normal to the surface. Therefore, you have something like this arrow. Should be normal to this surface. Look at this figure. Look at this ruler. It is normal to the right surface for the first reaction. So we should add it. This is first reaction force, Fn1. The second reaction force is from the second surface. And again, it is normal to the second surface, which is here. This is second reaction force. That's Fn2. And this is your free body diagram. There are three forces here. Okay, right now it's time to switch to Newton's second law, and we can discuss it and we can analyze some examples here. I want to talk about the horizontal motion. Actually, I want to apply Newton's second law for a particle which has rectilinear motion along x-axis. In other words, your particle has a rectilinear motion which is horizontal, like this. For example, to the right or to the left. And according to this motion, I want to apply Newton's second law. Therefore, over here, we have horizontal motion. Okay. Please recall the Newton's second law equation. What is this equation? It is F equal to ma. According to your problem, according to your condition, you have to draw the free body diagram for your problem at first. And according to the free body diagram, you have to apply Newton's second law and expand left side, because this is net force, and you have to apply all of forces along the motion to find net force. At that moment, it's ready to analyze the problem, and you can find the acceleration of your particle. I'll show it to you. But the first important part is free body diagram. Example. There's a box here. It's completely flat and it's smooth. And I'm gonna put the block on this surface, which is smooth. Okay. It has M mass, and mass is 2 kilograms. I want to apply a force here on to the right, like this. This is my external force. I want to apply this force by my hands on this block to the right. This force is, for example, 10 newtons. 10. If I apply this force on this block, which has mass of 2 kilograms, calculate acceleration. What is A? Okay, at first you need free body diagram. Therefore, separate your block, and you know what to do. Weight force downward. The next one is reaction from the surface. It is normal to the surface, and it is upward. Therefore, first one is W, weight. The second one is normal force, or Fn. And you have external force, that's 10 newtons to the right. Consequently, you have 3 forces. Okay. Where is this block? I'm sorry, where is the direction of this block regarding motion? I mean, the direction of velocity or direction of motion is to the right. Therefore, here, you have this coordinate here. You have this origin here. This is your origin, and that's to the right. Along the motion, apply Newton's second law. I mean, every force which is along horizontal motion should be applied for Newton's second law. F equal to ma. In other words, find net force along a horizontal line or horizontal motion. Okay, I'm asking, how many forces do you have along horizontal motion? Only 10 newtons. W is normal to this motion. And similarly, normal force is perpendicular to this motion. Therefore, you have to ignore them. Apply only 10 newtons. And this force, 10 newtons, is your net force. In other words, you have only one force, which is along your motion. Apply it. Therefore, it is 10 newtons. This is net force. Equal to mass is 2 kilograms times A. Therefore, A is 10 over 5. Sorry, over 2. And A is 5 meter per second square. Answer of the question. Next example. There's a block here on the flat, smooth surface. This is your block. There are 2 forces. First one, it is 100 to the right. 100 newtons. Second one is here. That's 25 newtons. To the left means you have two forces on this block. If the mass of the block is 10 kilograms, what is acceleration of this block? Find A. Okay, let's do it. At first, free body diagram. Separate the block. This here. Weight force down. Normal force from the surface up. Like this. W N. And here is 100 newtons to the right. And 25 newtons to the left. 100 newtons, 25 newtons. Therefore, okay. What do you think? Where is the motion of this block? Where is the direction? So if you look at this figure, you can figure out that 100 newtons, which is along x-axis, is dominant force. In other words, the first force on the left side, 100 newtons, is higher than the second force. Consequently, 100 newtons will dominate 25 newtons. Therefore, your block will go to the right. This is the direction of the motion. And along the motion, apply Newton's second law. In other words, ignore W and Fn. So apply it. F equal to ma. Pay attention, left side is net force. It means you have to apply all of forces along the motion to reach net force. Very important. Okay, now, what do you have along the motion? You should apply all of forces along the motion. At first, 100. You know, 100, it is along the motion. It is positive because there is an agreement between your force, 100, and the direction of the motion. Therefore, it is positive. 100, this is the first one. What is the next? What is the next force? It is 25. It is along x-axis, but it is opposite to the motion. Therefore, it should be negative. Apply negative sign because it is opposite force. Minus 25. Therefore, you should apply all of forces along x-axis. Maybe positive, maybe negative. This part is net force right now. And I told you, according to Newton's second law, net force will generate acceleration. Therefore, it is your net force on the left side equal to mass is 10 kilograms times A. Therefore, 75 equal to 10A. You can find A. A is 75 divided by 10 is a 7.5 meter per second square. Solve the question. Thank you.